So I'm going to be talking about the first derivative test. So let's do a problem. So if you're given a function f of x is equal or equivalent to x squared plus 6x plus 10, what you first have to determine is if it's continuous, the original function, on the closed interval a to b, and in this case, since it's a quadratic, it would be continuous, going from negative infinity to infinity, therefore spanning over all real numbers. And then the next thing you have to determine is if it's derivative, which you would just implement the power rule in this case. Plus 6, if the derivative is differentiable on the open interval a to b, and in this case it would be, since it's a line, so it would go from negative infinity to infinity, therefore spanning over all real numbers. So the domain would work in both cases. It would be. So then after you determine that, you have to set the derivative equal to 0 and then solve for x. And in this case, after you solve it, you'd get the x value of -3, which does fit in both domains. So that would be a true critical point. And after you've determined that, you have to sketch a number line and do test points around the critical point you just found. So I'll just pick -5 and 0. And the next thing you have to do is you have to plug in those test points into the derivative to determine their sign. So you don't necessarily have to solve it, you just have to know what sign it would have. So when you plug in -5, you'd get -4. So basically it'd be a negative value. And then when you'd plug in 0 into the derivative, you'd get a positive value, 6 in this case. So that would be a decreasing slope and like an increasing one. And basically that would get you a relative minimum. A relative min. And that's all you really need to determine for the first derivative test. Just keep in mind, though, that for the second derivative test, it's like the exact same process, except you'd be using the second derivative and determining inflection points, which is where the signs would be changing like it is in this case, going from negative to positive or positive to negative, and determining if it's concave up, which is a positive minimum, and concave down, which is negative, which is a maximum. And just keep in mind the other concepts we learned in this unit for the test. So